Welcome to Samveda e-learning class arranged for class 10 standard students. We will be discussing a very important lesson, arithmetic progressions. For our convenience, we have divided this into 5 parts. Today we will be taking up the first part of the lesson, arithmetic progressions. My dear children, if you observe, in the first column I have got 2 coins. I have added 3 coins which are shown in red. 2 plus 3 makes 5. Then to the 5 coins I have added 3 to make 8. To the 8 coins I have added 3 to make it 11, and so on. I have added 3 more to make it 14. As a result, what is it that I got? I got a set of numbers 2, 5, 8, 11, 14. Correct? Professor G.H. Hardy says mathematics, especially when you are dealing with numbers, it is all about patterns. So, heart of mathematics lies in the patterns. 2, 5, 8, 11, 14 has a definite pattern. Okay. Now, if you observe, another mathematician by name Steen has said it is all about signs of patterns. Numbers is all about signs of patterns. And he says a mathematician is like a painter or a sculptor. He is a maker of patterns. So, it is about patterns. Now, we have taken a set of numbers 1, 4, 9, 16. Correct? If you ask a student of mathematics or any lay person or a common man, what are these? He just reads 1, 4, 9, 16, or at the most, if he is a little sharp, a little alert, he might be able to tell you, sir, these are squares of natural numbers, sir. 1 square, 2 square, 3 square, 4 square. Wonderful, that's good. Then, my dear children, please watch. If it was 1, 4, 9, 16, they have been written according to some rule, namely n square, where n is a natural number. Let me take one more example, my dear children. 3, 6, 12, 14. These numbers are not written at random. They have been written according to the rule. Take the third example, 0, 7, 26, right? 0, 7, 26. Again, these numbers are not written in random. They are having some pattern. What is it? It is n cube minus 1. So, now the 3 sets of numbers that I have written, correct, they have been written according to some rule. Please note, they have been written according to some rule. They have not been written at random. So, it is nothing but the arrangement of numbers in a definite order according to some rule. Now, let me take some more examples, my dear children. 1, 2, 3, 4, 5, 6, 7, 3, 7, 11, 15, 19, 6, 12, 18, 24, 60, correct? These are numbers written. Again, not at random. I am following some rule. I am aware of which rule I am following. I will give you a couple of minutes. Will you find out what is the rule that has been followed in the first, second and the third example? See, if you observe 1, 2, 3, 4, 5, it is just the set of natural numbers. The rule is n. The rule is n. And if you go to the third example, 6 is 6 1s are, 12 6 2s are, 18 6 3s are. That is, it is following the pattern 6 into n, where n is a natural number. Correct? So, I have given you the rule that I am using in the first and the third example. I leave it to you to find out the rule that is being used in the second example. Take that as a little assignment and you can try it out at home. Okay? So, these are the list of numbers in which the difference between any 2 consecutive terms is a constant. Consecutive term, second and third term, or the third and the fourth term, or the fourth and the fifth term. You take any 2 consecutive terms, they have a constant difference, and such a list of numbers having a common difference between any 2 consecutive terms is called arithmetic progression. Now, my dear children, let us proceed with the lesson to understand some more. I have taken a number 2. What will I do now? Please observe. I am adding 5 to it, correct? I have taken a number 2, I have added 5, I get 7. To that 7, I will add 5 to get 12. To that 12, I will add 5 to get 17. To 17, I will add 5 to get 22. Correct? So, what has happened? I went on adding 5. I started with 2, added 5 to get 7, added 5 to get 12, added 5 to get 17, added 5 to get 22. So, that common difference, please observe, 7 minus 2 is 5. 12 minus 7 is 5, 17 minus 12 is 5, 22 minus 17 is 5. So, we went on adding that common difference to get this set of numbers or list of numbers 2, 7, 12, 17, 18. Hence, this is called, what do we call it? It is called an arithmetic progression. So, once again, this is another way of defining an arithmetic progression. In an arithmetic progression, the difference between any two consecutive terms is constant, and that constant is called the common difference, and it is denoted by the symbol D, small letter D. Now, we will see some more examples probably, or maybe we will be emphasizing on what we have already learnt. See, I have written 2, 4, 6, 8, etc. It is an arithmetic progression. Correct? Because they have a common difference. Check here, 4 minus 2 is 2, 6 minus 4 is 2, 10, 8 minus 6 is 2, or 12 minus 10 is 2, 18 minus 16 is 2. So, the common difference is observed throughout the series, right? Hence, it is an arithmetic progression. What is the common difference? Common difference is D, and it is denoted by the symbol D. And my dear children, now we will introduce one more term. The first term that you write is denoted by the symbol A. So, in any arithmetic progression, the first term is denoted by A and the common difference is denoted by D. Here I have A1, A2, A3 dash dash AN. What are this? It is just a set of numbers I have written. Instead of writing 2, 5, 8, 11, etc. In general, A1, A2, A3 dash 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 AN. These are all the terms, okay, and A1 is the first term, A2 is the second term, A3 is the third term. There are so many terms, and AN is the nth term. Correct? Suppose you ended with A10, there are 10 terms. You ended with A25, there are 25 terms. Now observe, my dear children, here A2 minus A1. What is happening here? It is the second term minus the first term. That is the common difference. Similarly, observe the third term minus the second term. It is the common difference. Now, I will start with the number 3. Okay. What am I doing? I am adding 2. I get 5. I add 2. I get 7. It is just a simple process. You all know. I have chosen the common difference to be 2. So, I went on adding 2 to get a series of number 3, 5, 7, 9, 11. This is an arithmetic progression. Maybe we will think of one more example. This time another child starts with 4. He is adding 3. You write down what is happening, let us see. So, you get 7. You went on adding 3 and 3. You got another arithmetic progression. Please make sure there is a common difference. So far we were adding the common difference, right? And all those common difference used to be positive. Either it was 2 or 4 or 5 or 7. For the first time I am taking the common difference as minus 5. So what is the first term I have chosen? 30. What is the common difference I have taken? Minus 5. 30 plus minus 5 is 25. Plus minus 5 is 20, plus minus 5 is 15, plus minus 5 is 10. This is also an arithmetic progression. So, in an arithmetic progression, common difference need not be positive only. It can also be negative, correct? That is why this particular example is taken. Now, observe, my dear children, we will give another definition. A list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Now, this is just to draw your attention. This is a calendar. You have got the set of dates. If you take the first column which is in red, 5, 12, 19, 26, right? This is a set of numbers. They follow a pattern, correct? What is the common difference? 5 plus 7, 12, 12 plus 7, 19, 19 plus 7, 26. Agreed? Am I right? Suppose you go to the column under Friday, 31. Go in the reverse order. 31 plus minus 7 is 24. 24 plus minus 7 is 17. 17 plus minus 7 is 10. So, under the Sunday column, the common difference was plus 5 plus 12 plus 19 plus. Under the Friday column, if you go in the reverse order, you are correct. You have 31 plus minus 7, 24, plus minus. So, common difference can be positive or it can also be negative. It can even be 0, okay. Fine. Here you have got an arithmetic progression 3, 8, 13, 18, dash, dash, dash. When I put dash, 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 we do not know how many terms are there. We call it as an infinite arithmetic progression or infinite AP. Here is another example, minus 22, minus 20, minus 18, dash, dash, 10. You know the first term is minus 22 and the last term is minus 10. That means we can find out the number of terms. Hence, it is called a finite AP. Even the third example is also finite, obviously, because there are 1, 2, 3, 4, 5 terms. It is a finite AP. Excellent. That's good, my dear children. Now, a small exercise is given to you. I want you to do it in a couple of minutes, right? You have got 2 by 7, 2 by 7, 2 by 7, dash, 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 right? First term is correct. Obviously, first term is 2 by 7. How will you find the common difference? D. Common difference is given by second term minus the first term, or third term minus the second term, or the fifth term minus the fourth term. Any two consecutive term, you should take the difference. 2 by 7 minus 2 by 7 is 0. Take another example, my dear children. 1.5, 3, 4.5. I am sure you have by now you have identified it as an arithmetic progression. 1.5 plus what you added? 1.5. 1.5 plus 1.5 is 3. 3 plus 1.5 is 4.5. So, first term is 1.5, common difference is 1.5. Take the second example, root 7, 3 root 7, 5 root 7. What is the first term? A is the first term, root 7, and common difference was 2 root 7. To root 7, you are adding 2 root 7, right? Now, just to exercise and to make sure we have understood how to find the common difference, 1 2 more examples are taken. Take the first example, my dear children, 3, 1, minus 1, minus 3, right? Okay. How will you find the common difference? Second term minus the first term. Which is the second term? 1. Which is the first term? 3. 1 minus 3 is minus 2. Okay. I will move to the second example. Minus 5, minus 1, 3, 7, right? How will you find the common difference? Second minus first. Second one is minus 1. Minus 1 minus of. You understood why I have to put a bracket there? Because they are in negatives. Minus 1 minus of minus 5 becomes plus 5. Minus 1 plus 5 is 4. So, the common difference is 4. So, this is how you can find out the common difference for a given AP. It is a small exercise, my dear children. Here, I will go on writing a set of numbers. You will have to tell me whether it is an AP or not. By now, you are sure how to decide whether the given set of terms is an AP or not, right? Wonderful. 3, 6, 10, 12, 15. Correct? I am sure by now we have realized. Is it an AP? Just check. 6 minus 3 is 3. 10 minus 6 is 4. There ends the matter. It is no more a common, it does not have a common difference. Therefore, it is not an arithmetic progression. Okay, done. Wonderful. Shall we take the second example, my dear children? 11, 22, 33, 44, 55. Correct? Is it an AP? Just check. Yes. 11 plus 11, 22. 22 plus 11, 33. 33 plus 11, 44. Plus 11, 55. So, what is that you have gone adding? 11, 11, 11. So, what is the common difference? 11. Do you see the common difference? Yes, obviously I see the common difference 11. So, shall we declare it is an AP? Obviously, you have to say it is an AP. Now, which of the following are APs? This is one more example. Be very careful. 15 minus 18 is what? Minus 3. 12 minus 15 is what? Minus 3. 9 minus 12 is what? So, you identified the common difference and therefore, it is a arithmetic progression. Check here. 19 minus 23 is minus 4. 15 minus 19 minus 4. 10 minus 15 minus 5. My God, I observed the common difference when I started with, but when I took the fourth term minus the third term, I did not get the same common difference. Hence, it is not an AP. Wonderful. So, by now you are very sure of what is an AP. It must have a common difference. Here, I have given you an AP 2, 4, 6, 8. I want you to find out the 20th term. I have written 4 terms dash dash dash. I want you to find out the 20th term. Will you go on adding? What is the common difference? 2, correct? 8 plus 2, 10. 10 plus 2, 12. Will you go on adding and tell me at the end of the day, sir, the 20th term is this? I don't think we will do it, and no mathematician would like to do that, right? We will see what to do then, right? I have got another AP 2, 5, 8, 11. I want the 536th term, my dear child. Will you go on adding the common difference 14 plus 3, 17, 17 plus 3, 20, 20 plus, my God, till you get the 536? No, we will not do it. What to do? How to find a particular term that I wanted? Let us see what should happen, how we go about, for which if you want to find out any particular term of an AP, 100th term, 50th term, 1000th term, you can find out, correct, but not by adding the common difference, for which mathematicians have thought of a brilliant formula, a simple formula. Okay. Before we arrive at the formula, let us see what will be the general form of an arithmetic progression. Any arithmetic progression, you have to start with the first number, call it as A. First term is denoted by A. To A, what will you do? You will add the common difference, A plus D, that is the second term. You have got A plus D. How will you get the third term? Add plus D, A plus 2D. How will you get the next term? Add plus D. You go on adding the common difference and you continue to get series of numbers which will be in AP. Correct? 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3, 14. That was a particular example. In general, first term is A. Add the difference D, A plus D, add the difference D, A plus 2D, and so on. So, this is the general form of an AP, of an arithmetic progression. Beautiful. Now, please take here, my dear children, 3, 7, 11, 15. I am sure by now, obviously, you have identified it is an arithmetic progression. What is the common difference? Can anyone tell me what is the common difference? 4. 7 minus 3 is 4, 11 minus 7 is 4, 19 minus 15 is 4, 35 minus 31 is 4. Suppose I denote the first term as A1, second as A2, third as A3 and the 10th term as A10. Okay. For convenience, I have named the terms as A1, A2, A3 up to A10. Okay. What am I going to do now here? The general form of an AP is A plus D, A plus 2D, A plus 3D, A plus 4D. Correct. A is the first term in that. I will denote it by A1. A plus D is the second one, A2, A3, A4, A5. Okay. Now, please have patience, give me little time, because I want you to generalize the formula. I want you to find out the formula to find out any particular term of a given AP. First example, A1 is A. A can be written as A plus 0D. That 0D has no value, it remains A. For convenience, A is written as A plus 0D. Observe in the next step that 0 is written as 1 minus 1. Do you observe in the bracket there? A2. A2, how do you get A2, the second term? First term plus the common difference. Which is the first term? A. What is the difference? D. A plus D. D is nothing but 1D, correct? D is nothing but 1D. That 1 is written as 2 minus 1. See the beauty of it. 0 was written as 1 minus 1. Correct? 1D. 1 is written as 2 minus 1. Take the second example. A3 is A first term plus d second term, plus d third term. 2 times you are adding d to get the third term. Beauty. That is a plus 2d. The 2 is written as 3 minus 1. Fantastic. In the fourth term, you have started with the first term a. How many times you have to add d? I added d to get the second term, another d third term, another d fourth term, a plus 3d. How will you write 3? 3 is written as 4 minus 1, no, beauty. So, observe that pattern there. It is a plus 1 minus 1 into d, a plus 2 minus 1, a plus 3 minus 1, a plus 4 minus 1, a plus 5 minus 1, a plus 10 minus 1, a plus 100 minus 1. So, the nth term of an arithmetic progression is an. It is denoted by an, my dear children. First term is a1, second term is a2, 10th term is a10. Any specific term, nth term is an. It is given by a plus n minus 1 into d. This is the formula which will help you to write down or to find out any term of any given AP. Okay? Beautiful. An is equal to a plus n minus 1 into d. It is a very sacred formula, a very important formula to find out the nth term. Just to recapitulate, you had 1 marble, 2 marbles, 3 marbles, and number of marbles goes on increasing. How many marbles will be there in the last row? It is given by an is equal to a plus n minus 1 into d. What we were trying to tell you is just to reinforce. What is an? Nth term. You want the 20th term? A20. What is a? First term. What is d? Common difference. Okay, that's good. That's wonderful. General form of an AP. So, any AP, any arithmetic progression, what will be the general form? You know the first term is a, second term is a plus d, a plus 2d, a plus 3d, a plus 4d, dash dash dash. The last term, correct, or the nth term, put it as the nth term, okay, call it as the nth term. Just now you proved that, correct, a plus 1 minus 1 into d, a plus 2 minus 1, correct, 2 minus 1 into d. So, in that you got a plus n minus 1 into d. So, this is the general form of an arithmetic progression. Now, to find the nth term from the last term, see, you will be given an arithmetic progression. They want you to find out the 10th term from the last, from the end. They want you to find the 12th term from the end. How do we do it? How do we go about it? Please observe. 3, 7, 11, 15, 19 is an AP, correct? Now, from the end I want to find out a particular term, correct? What do we do? Is there any formula that we can obtain? That is what we are looking at it, my dear children, now. You call the last term, that is 39, as L. In this given AP, it is a finite AP. 3 is the first term, 39 is the last term. I know the first term, I know the last term. Hence, I know definitely how many terms are there. It is a finite AP. So, you call the last term as L. Beautiful. Previous term, L minus D. If you want the next term, add plus d, add the difference. If you want the preceding term, subtract the difference. L is the last term. How did you get 35? Subtracting the difference. What is the difference? Can anyone tell me? 3, 7, 11. Sir, 7 minus 3 is 4. Difference is 4. Sir, 19 minus 15. Difference is 4. Yes, common difference is 4. So, 39 is the last term. What is the preceding term? L minus D. 39 minus 4, 35. 35 minus 4, 31. 31 minus 4, 27. So, you go on subtracting the difference. L minus D, L minus 2D, L minus 3D. Correct? Similarly here, just as we derived the formula a plus n minus 1 into d, here observe, L is the last term. Can I write L as L plus 0d? 0 is nothing but 1 minus 1. Or shall I write it as L minus 0d? I can. Correct. L minus 0d is L. And 0 is written as 1 minus 1. So, L minus, in the bracket 1 minus 1d. Now, L minus d, preceding term is L minus d. D is 1d. How will you write 1? 2 minus 1. So, L minus 2 minus 1 into D. Next preceding term is L minus 2D. How will you write 2? 3 minus 1. Correct. So, L minus 3 minus 1 into D. How will you write L minus 3D? L minus 4 minus 1 into D. Then don't you agree with me? The general formula is L minus n minus 1 into D. So, if you want to find any term from the last term, correct? If you want the 10th term from the last term, 20th from the last term, 16th term from the last term, you can use this formula L minus in the bracket n minus 1 into D, where L is the last term, n is, if you want the 10th term from the last, n is 10. 15th term from the end, n is 15, and common difference is obviously identified. That is wonderful, my dear children. So, to formula to find out the nth term from the last term is an is equal to L minus of n minus 1 into D. Now, having understood what is an AP and what is the general form of an AP, what is the formula to find the nth term of an AP, what is the formula used to find out a particular term from the end, we will work out a few problems to make sure we have a very good understanding of all the concepts that we have learned so far, my dear children. Here is an example. Find the 10th term of the AP 3, 7, 11. You want to find the 10th term, correct? If you want to find any particular term of an AP, or if you want to write all the terms of the AP. To write an AP, to find out an AP, you need to know the first term A and the common difference D. Am I right? Agreed. Now, find the 10th term of the AP 3, 7, 11. What is A? First term, sir. What is the first term in this case? 3, sir. A is equal to 3. Fantastic. What is the common difference? I do not know. But you know, my dear children, common difference is nothing but the difference between any two consecutive terms. Second term minus first term. 7 minus 3 is 4, 11 minus is 4. The common difference is 4. Correct? Now, you want the 10th term. What is the formula we use? an is equal to a plus n minus 1 into d. Correct? But you want the 10th term, no? So, a10 is equal to 3 plus 10 minus 1 is 9, 9 into 4, 9 4s are 36, 36 plus 3 is 39, therefore, the 10th term is 39. Shall we take one more example? In an AP, the 10th term is 39. See the beauty of it. 10th term is 39 and the common difference is 4. Find the first term. Please observe. 10th term is 39, A10. And they have given you the common difference to be 4. Beautiful. You have to find out the first term. How will I find out the first term? Use the same formula. An is equal to a plus n minus 1 into d. A is equal to 3. Thus, you got the first term. Summarizing, in any AP, A is the first term, D is the common difference, N is the number of terms. Okay, this is just the summary. So, arithmetic progression meaning, okay, we will just recall once again whatever we have defined, right. One definition is a list of numbers in which the difference between any two consecutive terms is constant, correct. Okay. Another way of defining an arithmetic progression, my dear children, is a list of numbers in which each term is obtained by adding a fixed number to the preceding number, correct, or to the preceding term, except for the first term. Okay, that is good. Then nth term of an AP is given by the formula an is equal to a plus n minus 1 into d, correct, that is good. What else we are looking at? Okay, nth term from the last term, most important. There will be usually a problem on this. 10th term from the last term, 15th term from the last term, nth term from the last term is given by the formula L minus n minus 1 into d. Correct? This is what we have learned today in the first session, I hope. Right? Now, your time. All the best, my dear children. Take care. Have a good day.